this is Street Smart Kids, and today I'm going to talk about a wonderful shape which we see everywhere, find everywhere, and I think you are well aware of it. It is nothing else but triangle. When three dots, any three dots in space, if you join them together, if you connect them together, they will form a triangle. Any three dots, anywhere, if you just make three dots, it will form a triangle. The shape which is formed is actually a triangle. Now, connecting dots makes a triangle. What happens if we open the dots? If we make all these dots stay on a line, this dot and this dot, I've just opened it and made it on a line, then it becomes a straight line, 180. Remember this always. I will tell you why I have given this point. So let's come back to the triangles first. Now, talking about the triangles, A, B, C. The most common triangle in your books you will be finding is A, B, C. Now, what is A, B, C? A, B, C is nothing else but the point on which the three lines have been connecting. We can call them as vertex. Okay? When the two lines are joining, they are forming a point. That point is called A. A is a vertex. And there is a small angle formed. Two lines joining, and the difference between the angles, these 2 points, is actually called an angle. So this is an angle, B will also be an angle, and C will also be an angle. So there are 3 vertex with 3 angles and 3 sides. What are the sides? Side AB, side AC, and side BC. Okay? Now, A, B, C. I said these are my vertices. This is basic of triangles. If you don't know anything about triangles, this is the right time you should start learning about these points. A, B, C. The angles are also can be called as angle A, angle B, and angle C. So there are 3 angles of this triangle, and the lines AB is a line, BC is a line, and AC is a line. Now, AB can be also written as BA. I am talking about line. If I talk about direction, in which direction, then AB and BA is not the same. But suppose I tell you that AB is extending towards X, then I will not say that BA is extending towards X. I will say AB extend towards a point X. So if this is not mentioned, like without a direction, scalar values, these are known as scalar. Scalar values, we can write AB and BA. They are the same thing. Same thing, BC and CB can be written the same way. It's just a line. We can write either this way or this way. And same thing with CA. So these are known as my lines of a triangle, and these are basically my angles. Okay, these are angles. If I be more specific, I can say that these are known as internal angles. Why internal? Because they are inside the triangle, because of obvious reasons. Okay, Acha. Another thing, if this is my angle A, even this is my angle A, because I have just widened the angle. It's the same, even this is my angle. Don't think that out of these 3 angles, this angle is the smallest. No. If I widen this, the same angle is angle A. Alright? So this is the basic learning about what are angles, sides, vertex, and so on. Okay? Now, I had given you an information about the straight line. If you open the triangle, then it is going to become a straight line. Basically, what I wanted to say that these 3 angles, that is angle A, angle B, and angle C, they are always in a relation. A triangle with 3 angles will always have one common relation, and that relation is these 3 angles addition will always be a straight line. I showed you joining these three dots, but if I open the dot, then it will become my A, B, C will become my ABC. What is this angle? It's a total straight angle. So addition of these three will always become 180 degree. This is the first and foremost relation that you should know. The addition of the three internal angles of a triangle is always 180 degree. Remember this, whatever happens. If it is not 180 degrees, that means it is not a triangle. Suppose I give you three angles like 40, 50 and 30. Okay? Is it a triangle? 40 and 50, it becomes 90. 9, 10, 11, 12. The addition is coming as 120. Is it equal to 180? No. That means these three are not the angles of a particular triangle. They can be angles, but in separate ways, not in this particular triangle. Clear? So this is the first and foremost rule that you should always remember regarding this. Alright, this is the first rule which I have discussed here. Now, when I spoke about the interior angles, then you must be aware that there is another thing known as exterior. Obviously, if there is an interior, there has to be an exterior. So, suppose I extend my line. Okay, then this line, this angle which is being formed by these two lines, there is one angle which is interior and there is one angle which is known as an exterior angle. Okay, similarly, if I extend a line here, this is also becoming my exterior angle, and if I extend my line towards this side, this will be my exterior angle. Okay, but do you think that there are only three exterior angles in this case? No, there are more. Now how will I understand this? I have extended the line BC to Q. Okay, now if I don't extend this line and if I extend in this case to P, that means what? That means this will become my exterior angle. Okay, if I omit this and I extend my line till this much, that means this is my exterior angle, and if I omit this, then this is my exterior angle. So one angle can have two exterior angles. Alright, similarly in this case, as I've extended this angle here, that means this was my exterior angle. Now if I extend my angle here, that means this will be my exterior angle. See, I have removed this, so I hope you can see this is my exterior angle. Similarly in this case, this is one exterior angle, and if this line gets protruded in this way, this will become my C. This is my internal, so this will be my exterior angle or external angle. Okay, so this is how I can say there are different exterior angles of a triangle. Okay, now in parallel lines we have learned that when two lines meet at a point P, we know this angle, suppose X, and this angle X is always same. What is the reason? The reason is they are vertically opposite angles, and in this case, if this is Y, this will always be Y, also vertically opposite angles. Correct? Now I hope you remember this. What about in this case? In this case, look into the red angles which I have drawn for angle C. This, if you consider, isn't it? This angle is exterior, this angle is exterior. these two angles are vertically opposite angles, isn't it? This one for this and this one for this. That means these two angles are same. So if I just hit one of them for this angle C, my linear pair for this is my C dash, that is the 180 minus C. This will become 180 minus C. And if I hide this, if this is angle C, this will become 180 minus C for obvious reasons, because this is a linear pair, correct? And in this case also, this was a linear pair. So can you see that these two angles are same? And obviously this will also be the same because of this vertically opposite funda. Okay? Just to tell you that don't think this is an external angle, because this angle and this angle are always this will be same. These two are known as exterior angles. Okay? So while judging an exterior angle, always make sure that you are looking at the straight line, finding out the 180 minus this angle which is being mentioned. Clear? So this concept of triangle is very, very clear. Okay, my next types of triangles. What are the different types of triangles? Based on their sides and angles, we can determine the different type of triangles. For the first one, if I say, if in a triangle all the three sides are equal, x, y, z are suppose three angles, and if I see that x, y and z are equal, then I will call it as because of equilateral. Okay? Equilateral triangle. Now what did I know? That these three means addition of these three is 180 degrees. That means what is my each angle? 60, 60, 60, 60. That means x is equal to y is equal to z is equal to 60. That means 60 plus 60 plus 60 means 180 degree. Hence I can say this is an equilateral triangle. Okay? Next I come to this. Suppose in case of x, y, z, again if I say that x is equal to y, these two angles are equal, for example, then what will I say? If any two angles of a triangle are equal, then they will be called as Isoceles Triangle. Okay? For this, if you have an eye in this side and you are looking in this direction and this direction, you will see that these two lines are actually the same. That means this line and this line are actually same. In which case, where the two angles are equal. Suppose I am a vertex and this is my triangle. These two angles are equal. That means these two lines will also be equal. Okay, in this case. I hope you understood. Vertex, these two are sides. So this line is same and this angle is same. This is called a isosceles triangle. Next, in again x, y, z, x is not equal to y, not equal to z. That means all these three angles are not equal. They are different. Then this will be called as scalene triangle. Alright. Now in this case I can tell you, like suppose x is equal to y and suppose they are 40 degrees each. 40, 40. But that means it is 80. Then what will be my z? It will be obviously 180 minus 80. That is, it is 100 degrees. So this can be a possibility. Any one of the triangle can have this. Now instead of x, if I have 50, that means 50, 50, 100. Then what is my z? It will be 180 minus 100. That is 80. So this is just one example of an isosceles triangle. Okay, this is like the only example of an equilateral triangle, because these three angles are actually 60 degrees, 60 degrees, 60 degrees. That means they are in the ratio of 1:1:1. Clear? Alright. In case of scaling, I told you there may be different angles. Suppose x can be 40, y can be 50, z will be 90. 40 was 90 degrees. These three angles, each of them angles are different. So it's an example of a scaling triangle. Talking about the 90 degree, if a triangle has 90 degree in any one of the angle and the angle either x or y or z, if any, will be is equal to 90 degree, then this will be known as a right angled triangle. Clear? Alright. This can be either 40-50. Okay. This can be 30-60. Okay. This can be 20-80, or maybe in other numbers also. Alright. So this is known as a right angled triangle. Now, right angled triangle, clear? One thing you will always remember, in case of a right angled triangle, suppose this is x, y and z. If my y is a right angled triangle, x and y always will be less than 90 degree, because of obvious reason that my total angle is 180. So if one angle is 90, obviously these triangle has to be less than 90, isn't it? So x and y will always be an acute angles. And so I can say this particular triangle will be an acute angle, right angle triangle. Clear? Why did I say this acute? Because x and y has to be less than 90. Suppose this is 90 and my x is 90. So 90 plus 90 is 180 degree. Now what about z? Already it has completed 180 degree. Now where will my z angle go? So never ever it can be equal to 90 degree. It always has to be less than 90 degree to fulfill this criteria. Okay? So this is about my equilateral, isosceles, scalene, acute angle. Okay? Well, now this can be another case. Suppose my x and y are same and my third angle z has become 90 degrees. So 90 degrees means I will blindly say it's a right angle triangle. But if my x and y are same means obviously this will also become x in that case, in this particular case. So x and x same means I will say it is a isosceles right angle triangle. Alright? Isosceles right angle triangle. These two are considering to be same. So if you calculate, if one is 90, that means the addition of these two also has to be 90 degree. That means my x and x will be how much? 45. Isn't it? Do you understand? 180 minus 90 means what? My answer will come as 90 degrees. Now they are saying that these two are same. That means it will be 90 minus 2, which is 45 degrees. Okay? So these are my special type of triangles, and there will be sums and sums and sums based on this concept. You just have to look at the triangle, look at the angles that has been mentioned and do the sums. It's as simple as that. Alright, I think I've completed all my laws. One particular law is left which I would like to tell you. Let's consider, suppose, any one of the triangle. Okay, let me draw a fresh triangle for the time being. Now in this case, as I told you that the sum of the three angles of a triangle is 180, there is a law for the sides also, A, B and C. There is a rule that addition of any two sides AB and BC will always be greater than the third side CA or AC. Okay, suppose this is 10 centimeter, this is my 6 centimeter. This will not be 4 centimeter. Why? Because 6 plus 4 is how much? 10. Addition of the two sides will always has to be greater than the third side. Is it becoming greater? No, it's becoming equal. It has to be always at least by 0.1 centimeter. Mane ki 10.1 centimeter is greater than 10 centimeter. Minimum I am talking about. Minimum it has to be greater by 1.1. Okay? Addition of any two sides. Suppose if you consider 10 and 4.1, it will become 14.1. 14.1 will always be greater than the third side. Okay? So this is another rule which you have to understand. I think that's it. Now there will be next videos where you will try to solve the sums using these concepts. Okay? Yes. Talking about the internal angles, we've done external, we have done different sides and so on. So my last rule which I would like to tell you, that if I draw a triangle with one external side, suppose this is X, this is Y, this is Z. I am naming this as angle P. P is a very sweet alphabet. So, suppose if I am naming it as P, my rule is an external angle. This external angle will always be equal to the addition of the opposite internal angles. This is my linear, but this is these two angles A and X and P are not linear. They are opposite. P and Y, they are opposite. So I will say angle P is equal to angle X plus angle Y. External is equal to the addition of opposite internal angles. Alright? Now, if you consider this angle Q, that means Q is external here with reference to Y. That means what is the other two angles left? X and Z. So I can say Q is equal to X plus Z. External is equal to addition of opposite internal angle. Suppose if I take an angle as R. R is linear with X. Okay, you can write this point. Q and Y are supplementary. Okay? That means addition of these two is 180. Okay. P and Z, they are supplementary. You can write it like this. In case of R, what will I write? R is equal to, this is R, so addition of this opposite internal angle, that means it will be Y plus Z. So R is equal to the opposite internal Y plus Z. Why? Because I know external angle I is opposite of Y and Z. Okay? What about X and R? My R and X, they are linear pair and they are supplementary. Clear? So internal, external, their relationship, the sum of three angles is 180. Two sides is always greater than the third side. What are the three different type of triangles? Isosceles, scalene, equilateral. What is an acute angle, which is always less than 90 degrees, obtuse greater than 90 degrees, and right angle equal to 90 degrees. So with these relationships, if you look into the video again and again, you will understand that triangle is very, very easy. Okay? You will be able to solve sums based on these equations, on these laws. I will help you out with some sums. I will deduce some sums and I'll help you with this.